So in chapter 10, we have learned about different uses made up of metals like aluminum, can, copper wires. That by our common sense, we know the metals would be quite useful in our daily life. But in chapter 11, we have also learned that metals will react with water, oxygen, which will be present in the air. But that would be quite annoying if your metal application turned into something unuseful. That would be the metal oxide and the metal hydroxide. Right, so that's why in chapter 13 we will learn about the conditions for rusting of iron as an example of corrosion of metals. So corrosion is a larger set. Right, it is the slow reaction of metal, right, any metals with air, water or other substances in the environment. So as we know that the reactions of metal will depend on the reactivity of metals, so the more reactive metals corrode at a higher rates. Okay, and in this chapter only corrosion of iron is studied in details. Corrosion of iron is called rusting specifically, so don't mix up these two terms. Corrosion means corrosion can be used for any metals, but rusting can only specify the corrosion of iron. In the first stage of rusting, iron 2 ions must be produced after before all the other complicated chemical processes. So we write here Fe become Fe2 plus and losing 2 electrons actually. Okay, iron 2 ions are then involved in a series of chemical changes. And in these changes, water will be involved. Right, so that's why water is required for rusting process. Also, the oxygen will be involved to make up the iron 3 oxide. So the product hydrated iron 3 oxide is the rust we can see in our daily life. If you recall the appearance of the rust, that should be reddish brown in color. And the formula of it is what we can see here, Fe2O3 dot NH2. It is an ionic compound with the water of crystallization. So for the overall equation, we have 4Fe plus VO2 to give, and also 2NH2O to become the hydrated iron 3 oxide. So in science, we always want to prove what we think about is correct. So in this session, we will introduce an experiment how we can prove that the need of water and air for rusting. So as you can see, you have 3 cells A, B, and C. So in tube A, water is absent for rusting because anhydrous calcium chloride is a very common drying agent in the laboratory, and thus it absorbs the water in the air. Without the water, then the iron layer will not be rust. In tube B, oxygen is boiled out. So that means the test tube is under boiling for propelling all the oxygen inside out of the test tube. And then the oil layer floating on the water is used to avoid any further entry of the oxygen from the air. So C, we haven't done anything, we just put the iron layer into the water. So you can see that A and B is what we call the control experiment of test tube C. So you will expect that only test tube C, the iron layer in test tube C would rust, right, to give you the brown appearance solid. So after we know that how rust can form, we want to know that what will affect the rate of the rusting, so that we can do something to slow down or even avoid the rusting of our daily life applications. So we have just said the formation of Fe2 plus is the first step of the reaction, and at the same time it's the slowest one, which can determine the rates of the reaction. Just like when you cooperate with your classmates to do a project. So you have done your part, and you still need to wait for the others to finish their part before you combine the PowerPoint or the project. Okay, then we say that the slowest one who can complete the project is the one who determines the rate of finishing the project. Alright, so that we call the slowest step usually in the complicated chemical process to be the rate determining step. So any factors affect the rate of this step will essentially influence the rate of rusting. So before we proceed to look at different factors, you can imagine what factors would affect the formation of Fe2+. Then you will know that what factors will affect the rate of rusting. So you can see here the obvious factor would be the temperature. You know, if the temperature is increased, then all the reaction will increase as well. A higher temperature speeds up the formation of Fe2+, and thus the rate of rusting. Second, in the presence of electrolytes, it increases the conductivity of the reaction mixture. So this facilitates the movement of ions and therefore the formation of Fe2+. So let's look at the process of rusting in detail. So you know that the first step Fe needs to release 2 electrons before it undergoes the complicated process. So at the same time, there must be something which accepts the 2 electrons, which is the oxygen in the air. So the oxygen will accept 2 electrons together with water to give the hydroxide ion. So if the Fe2+ cannot be moved away, then its presence will inhibit the further presence of Fe2+. You know, the same charge will repel. Then that means the rate of the Fe releasing electrons will be slowed down. Increasing the conductivity can help the movement of the ions and therefore the formation of iron 2 ions. In particular, you need to pay attention to those acidic solutions because they speed up the rusting because it reacts with iron to form Fe2+. If you recall your memory in chapter 11, right? It speeds up the reaction of iron to release 2 electrons to become iron 2+ easily. So at the same time, it increases the conductivity as well because of the hydrogen ions presence. So that means if we use acidic solution, that will be very efficient for the rusting process to occur. First, it speeds up the formation of Fe2+. Second, it also increases the conductivity of the solution. So third, those sharply pointed regions of the iron will rust first because the irregular arrangement of iron atoms would make the electrons easier to be escaped from the attraction of metallic bonds. So you can draw it out in a paper. If you have 2 ions, right, in between you have the electrons, but at the sharply pointed region there may be 2 ions and then the electrons. So that means the repulsion of the ions itself facilitates the release of electrons. Facilitate the release of rate of formation of iron 2+. So each time when you are explaining whether the rate of reaction is affected, you come back to the rate of formation of iron 2+. That will give you 1 mark. The presence of another metal is a very common way to monitor the rate of reaction of rusting. So the less reactive metal facilitates the rusting of iron. For example, tin. That is the reason why I asked you to remember the reactivity of tin. So it if you have a less reactive metals, since you build up the potential, a more reactive metal would like to release electrons more, then it would speeds up the release of electrons of iron. At the same time, more reactive metal inactivates the rusting of iron because the more reactive metal itself would release electrons. So it slows down the release of electrons of iron. So far we have explained the conditions of the necessary conditions of rusting, and at the same time why the rate of rusting will be affected. Right, the main reason must be the rate of formation of Fe2 plus be affected. Right, we have 4 factors: temperature, presence of electrolytes, sharply pointed regions, and the presence of another metal to affect the rate of formation of Fe2 plus, and in return increases the rate of formation or increases the rate of rusting. So now it's your turn. Please finish these 2 multiple choice before you come back to the lessons. During the lessons, we will try to do the long question in the chapter exercise in order to facilitate your presentation skills in the exam.